Yeah, very good afternoon to one and all. So yesterday we have discussed about this ANOVA, right? So we are at the end of the ANOVA, and then due to some time limit, we went up. So we'll continue this one, and then we'll go for the today's session topic. Okay. So see here. Yesterday, what we have performed is that we have taken the population, we have generated from the population, we have taken some samples and we have verified that whether the samples are equal to whether the samples are actual representative to the population or not. So we have verified by taking the characteristics is mean. Okay, so just sample mean is equal to population mean or not, or whether if I take two sample groups and these two sample group means are equal or not, or if you have more than two samples and we are working with ANOVA. Okay, fine. So now here let us take here what we have considered yesterday. We have considered three different groups, I mean three sample groups, and we have compared with the means. So now the same ANOVA I will perform with original data set, and you can easily understand what instead of going with the random number generation, so how this ANOVA will be useful for the real life data, and then multiple comparison tests, that is pairwise comparisons. So yesterday I said, right, so whenever the ANOVA, analysis of variance, so when we are in the rejection position of the ANOVA, I mean, if we reject the null hypothesis in the ANOVA statement, then we have to go for further investigation. So that we will do now. Okay. Generally, the ANOVA rejection will comes in the real life. So most of the times in real life, so always we are going with the rejection of the null hypothesis under ANOVA test. Why? Because multiple groups we are comparing, and there may be some situation that if you have one group is showing some different, significant different other than the remaining groups, then automatically the entire ANOVA will be rejected. Okay, that's why I will show you that one. So I will take a new manuscript. Yes, new script I got. So here we'll perform. Let us say the same data set. What we have already we have some experience, right? So on empty cast data set. So let's go with the same data set and we'll work on this ANOVA. Okay. So just I'm visualizing. So head of empty cast data set. Just I'm visualizing. So first 6 records of my data has been shown here. Now in this data, so generally we are working on mileage, right? So mileage, MPG. Yesterday we performed regression analysis. So mileage, cylinders, displacement, horsepower, DRAT, and all these things is there. And here you can see this. For example, let us will go with cylinder. Yesterday we came to understand that so cylinder is also one of the main factor which is showing effect on our mileage. So we performed a variable selection procedure, that is stepwise regression, forward selection, backward elimination. So in that we came to know that so cylinder and weight, these two variables are showing some better significant effect on the mileage. Okay, let's go with this cylinder will perform ANOVA. Generally, what we want to, how we will perform ANOVA. ANOVA will be useful. So to compare more than two group means, let us take, if I take a cylinder. So just we see the number of levels, I mean number of categories that a cylinder is having. Just go like this. So factor. So factor is a command. In the first class we discussed it. So factor is a command which will be useful to see the number of levels in the particular variable. So here I'm taking cylinder CYL. So if I run this one, object CYL is not found because we did not attach the command, that we cannot access the variable names directly in the data set without attach the data set. This is we know already. So just I'm attaching data. So attach empty cars. Yeah, so attach now factor CYL. Now see here, this is having, so there are three categories are there. So these are 32 observations, I mean 32 different cars, Mazda RX-4, Mazda RX-4 WAG. So like that there are 32 different types of cars we have. Now these 32 cars having different cylinders. So some cars is having 6 cylinders, some cars is having 4 cylinders, some cars are having 8 cylinders. Now, for example, my interest is that if I want to if you want to go for purchasing of a new car, for example, let us take I want to buy a particular a Mazda RX or Mazda or some BMW car. Now, this cylinder we understand using regression model, cylinder is showing effect on the mileage. Okay. Now, my interest is that I want to get a good mileage based on if I want to get a good mileage, then by using this data set, I'm comparing whether is there any significant effect of the 6 cylinders or 4 cylinders or 8 cylinders cars showing the effect on the mileage. Like that, if you want to compare, then we can go for ANOVA. There ANOVA will be that is the only purpose. No, you want to compare the different means of more than sorry, the means of more than two groups. The same situation here. Now I am in a situation that I want to compare the means of the 4-gear cars and 6-gear cars and 8-gear cars. So these are the three groups, different types of cars are there. Now I want to compare which group cars are having more mileage, or is there any equal mileage is giving between 4 gears, 6 gears, and 8 gears? Is there any significant difference exists in the mileage based on their cylinders, number of cylinders? If I want to know, directly we can go for the comparison of these three groups using ANOVA. Okay, so let's go with this symbol will perform ANOVA. So how we will perform ANOVA? AOV. So AOV is a symbol command to perform analysis of variance. So ANOVA. So within the bracket, first we have to indicate what is our dependent variable. So my dependent variable is nothing but mileage. So we are comparing the mileage only, right? So let's go with mileage. So MPG, next tilde. So what is our categorical variable? Categorical variable cylinder rate. Just take like this, factor of cylinder, CYL. So this is a factor of CYL we are considering. Now what we are saying that, so I want to compare the mileage MPGs based on the factor variable cylinder. Cylinder is having three factors. One is 4-gear cars, other one is 6 gears, other one is 8 gears. Okay, these 32 observations, 32 cars are divided into three categories. Some cars are having 4 gears, some cars are having 6 gears, some cars are having 8 gears. Now, based on that, I want to compare. Now, let's go with the data. So, just I will indicate data where I'm taking. That is, data is taken from empty cars. This argument sometimes it will ask, sometimes no need to define. Why? Because already we attach the data, right? So maybe may not be, so doesn't matter here. Okay, just I'm giving full code. Okay, so AOV, MPG, factor variable is CYL, and data equal to empty cards. So I got the output. Now I will take the summary of this model, then easily I will understand what my ANOVA table tells us. Summary. Now let us store this ANOVA table in any one object. Let us take ANOVA, right? So ANV, let us simple I will take. Yesterday we stored ANOVA. So today I am storing with the ANV. It's an object I have created. Now I have stored this output into ANV. We can explain this output also, what with the output we are getting from this ANOVA model. But generally in all theoretical framework, ANOVA means we have full ANOVA table. In that ANOVA table only we know how to give interpretations. But using this residual sum of states and degrees of freedom also we can give interpretations. But basically if you study any statistical textbooks, directly we'll get ANOVA table. From the ANOVA table we are going to give a decisions. That's why, so instead of explaining this output, so I'm also going with directly ANOVA table. Okay, yeah, let's go with like this. So summary type of mistake, right? So summary summary of ANV. So this is my model summary. First let me run this one, ANV. Yeah, executed. Now summary of ANV. Yeah, so this is complete ANOVA table. Okay, see factor variable is cylinder, and now we got the proper way. So yesterday what the mistake is we did is nothing but, see I will show you. Yesterday I have tried, after performing this one, I tried a lot to what is the problem in this and why this it is getting only 1 degree of freedom. Yesterday if you remember, here we got 1 degree of freedom. So there are three groups, that is this group sample 1, sample 2, sample 3, and if I execute this one, so 3 minus 1, that is k minus 1 should be there. So 3 minus 1 should be 2, but here yesterday we got 1. So the problem is that here you can see this one, sample group GRB is there, no. So we have taken groups directly as a variable without mentioning as a factor. Today I have mentioned as a factor. Here you can see this one, factor CYL. So we have to indicate in the ANOVA. So the independent variable is a factor. This is a category wise data. So according to this, we have to divide. Same thing yesterday, we did not perform here. This should be factor of now sample groups. This if you define like this, no, then we are getting proper answers. Yesterday we did this mistake. Okay, yeah, fine. Clear. So here I'm taking the real data set, right? So we got this ANOVA table. Now in this ANOVA table, we can see this the factor level, that is CYL. So there are three groups, 3 minus 1, that is 2 degrees of freedom. K minus 1 you will get, and residuals. Residuals are nothing but so errors. So error degrees of freedom, source of variation due to errors. So there are totally n observations. N minus 1 will be the degrees of freedom with total degrees of freedom. Okay, residuals n minus k. Now n is, there are 32 observations are there, minus k, 3 groups. So 32 minus 3, you will get 29. And then sum of space. These are the formulas we have. So we need to use the formula to calculate the sum of space for group wise and sum of space for the residuals. Next, some mean sum of square. The mean sum of square value we will get. So sum of square value divided by degrees of freedom. And sum of square value divided by their corresponding degrees of freedom, we will get mean square. So if you want, you can verify. If 824.8 divided by 2, you will get 412.4. 301.3 divided by 29, you will get 10.4. So like this, we will get mean sum of squares, and taking the ratio of these two mean sum of squares. One is factor, other one is residual. So take the ratio of these two mean sum of squares, you will get F value. The 412.4 divided by 10, you will get 39.7. This is the ratio of this mean sum of squares, and this is the corresponding p value. This p value is calculated with the formula probability value. Okay, so in our normal theoretical statistics, we will get up to p value. Then we are going with table value. So what is the table value at degrees of freedom? Degrees of freedom is 2, 29. So in F table, we will see 2, 29 degrees of freedom at any level of significance. For example, let us 5% level of significance table we will see, and we will find the table value. Now we'll compare the calculated value. That is, what is the calculated value? 39.7. So with this calculated value, we will compare the table value, and if the calculated value is less than the table value, we are accepting the null hypothesis. If the calculated value, that is 39.7, is greater than the table value, indicates so there is a significance, that is rejecting the null hypothesis. Okay, but here in the programming languages will not give any table values, so does not require to see, does not require to look into tables at a particular degrees of freedom. Okay, so this will generally will give the p values, and we, as one day I said, right, if you identify the stars in the data, there may be a significance. Okay, see here the p value 4.98 e to the power of minus 0.909. So minus indicates so the value, the value before we have that many zeros. Now 9 zeros are there, that is 0.000000498, like this. So there are 9 zeros prior, and then the value is there. So which means that the p values are almost close to 0 exactly. Also we can say sometimes, why? Because after 9 decimals, so you are getting 0 is value is nothing but, so we can round it to 0. So p value is 0. What is mean of p value is 0? So when the p value is less than 0.05, we are saying that it is highly significant. We are going to reject the null hypothesis. Here directly indicates in stars. So stars directly indicating us. So there is a significance, high significance exists. So which means that we are going to reject the null hypothesis that indicates. So there is a significance difference between the mean mileage of the cars which are having different cylinders. So the mean mileage of the cars are different across their cylinders, which means that 4-gear car cylinders and 6-gear car cylinders are not having equal mileage. At the same time, 6-gear cars are not having 8-gear cars. Like that, any one group is not having equal mileage. This is the indication we got now. Now, see the null hypothesis in this degrees on our table, we got that. So there is a significance difference exists between the mean mileage of the different car cylinders. Okay, now further we have to go for investigation. So once we reject the null hypothesis, we should not stop in ANOVA. But most of the statisticians or general any investigators, once they will do data analysis with this ANOVA, so they will not further focus. If it is accept or reject, that is the only matter for them. If it is reject, no, they will say, sir, my null hypothesis is rejected, I got significance, I can say that my model is best. Okay, but once it is rejected, further investigation we have to do. What the investigation? Here we have taken 3 groups, right? 4-gear cars, 6 gears, and 8-gear cars. So if any 1-gear cars or a one group of gear cars is different mean mileage, other than the two good groups, then definitely you will get rejection of the null hypothesis. But there may be a situation that, for example, 4 gear cars, 6 gears are having equal mileage, or 6 gear cars, 8 gear cars may have equal mileage, but not with the 4 gear cars. Like that, any group, two group means maybe coincides with, and which will not be coincide with the other group. So if you have that type of situations, right, that we have to understand further also. So we have to go with pairwise comparisons. So once the null hypothesis is rejected, then we have to go for pairwise comparison purpose. So if you want to go pairwise, so pairwise comparisons we will call, multiple comparison test we will call, all post hoc comparison test we will call. So they are all are same, okay, according to the different words calling. So there is a different meaning, but all are same only. Pairwise comparison, multiple comparisons, post hoc test. Okay, now I will go with pairwise comparisons. Why? Because my null hypothesis is rejected. So these three groups are different. Now I want to know which group, either maybe all groups are different or any two groups only different, that I want to further investigate. Okay, so now I'm going with post hoc tests. Post hoc test. Yeah. So now we are going with post hoc test or multiple comparison test. Okay. Or multiple comparison test, MCT. Okay. So if you want to perform multiple comparison test, so we have to install the package. So multicom. Okay. So I will use this one. Multiple comparison. That is multicomp. So this is the package required. So package required. So multiple comparison is a package is required. So we are going to installation of the multiple comparison package. So packages install mult got c multcom. This means the multiple comparison test. So this is a package required. So just I'm installing. Yeah, fine. Here we'll go with search of that one, multi comparison. Yeah, we got. So multiple comparison this one. So simultaneous inference in general parametric models. Fine. So yeah, I have loaded this multiple comparison test into my R console. Yeah, successfully loaded. So one is installation, other one is loading into R console. Now the code is, so here, once we install and loaded this multiple comparison test, so under multiple comparison test, there are different tests are there. One is done test, or done it, or Tucky, or Skiffy. So these are the different tests. Multiple pairwise comparison tests are available in our under this multiple comparison package. Okay, among all these are the author names. They are developed different processes to compare pairwise observations after rejecting the null hypothesis in the ANOVA. So among all these techniques, you can use a Tucky HSD test. Tucky test is very useful. Okay, which gives you approximately exact results, exact comparisons between pairwise groups. Okay, so among all these things, I'm going with only simple test, that is Tucky HSD. So Tucky, TUK, just you type one letter, one or two letters, you will get this one. Tucky HSD. What is this Tucky HSD? HSD is nothing but highest significance difference. Sometimes it will take LSD also, least significance difference. So Tucky LSD or Tucky HSD, these two techniques you will get. So what is this highest significance difference is nothing but. So now we are going with pairwise comparisons, right? So three groups are there. So three groups means first one, two comparison, 2, 3, one more comparison, 1, 3, one more comparison. So while comparing this one, so it is going to consider what is the highest significance difference. If there is a highest significance difference HSD exists, then we'll say that there is a significance difference between these two groups. So based on the HSD. Otherwise, it will sometimes it will consider least significance difference (LSD). If there is a less significance difference, we can say that both the groups are equal. If there is a more significance, both the groups are not equal. So like that, so based on some tests, it is going to perform. Okay, that's simply they named as Tucky HSD or Tucky LSD. HSD is the highest significance difference. So Tucky is author name. Okay, fine. So Tucky HSD. So what is our model? ANOVA, right? So A N V. Just give that one. That's it. Now we run it. See simply. So Tucky HSD, ANV, the model Tucky multiple comparison of means 90% family-wise confidence levels. So accurately 95% confidence level is following. Next, this is the fit, how the model is fitted. Next, factor, cylinder-wise. See, 6 gear cars and 4 gear cars comparison. Next, 8 gear cars and 4 gear cars. Next, 8 gear cars and 6 gear cars. There are three different groups, three pairwise comparisons we got. So 6 gear cars and 4 gear cars. What is the difference between their mean values? The mean average of 6 gear cars and 4 gear cars difference is minus 6.92. And what is the lowest value for this significance? If you go for sampling, what is the lowest confidence intervals, what is the upper confidence intervals, and what is the p value? You can consider this p value. So this is a significance difference minus 6. So 6 gear cars are having less mileage than the 4 gear cars. Why? Because 6 minus 4 we are taking. So 6 gear we are got the negative values. No, negative values means the first value will be lower. So which means that 6 gear cars are having low mileage than the 4 gear cars. So approximately their mileage difference is 6 miles. 6 miles difference existing in the mileage average. Now what is the p value showing? 0.00034. So which is here you should not consider the p value directly with 0.05. Why? Because 0.05 is for the original model. Now these three groups we have subdivided, right? How many groups we are there? Three groups, right? So this 0.05, the level of significance also we have to subdivide. So we have to take divided by 3. How we will take divided by 3 is simply I will show you here. 0.05 divided by 3. Now what the value will get? 0.016. This is your cutoff value now. You should not take the p-value and should not compare directly with p-value 0.05. Why? Because so in the ANOVA table here, in this ANOVA table, in the ANOVA table we are now previous here. So here we are comparing the p-value with exact one 0.05. Now this ANOVA model again we have subdivided for pairwise comparisons. The groups are three groups we got. Now that 0.05 should be divided by 3. Okay, now what the p-value we have? 0.016. Now take this p-value and compare with these groups. Now see 0.00034, which is less than 0.01. Yes, am I right? Yeah, it is a significance. Next, it is almost zero significance. And this one is 0.01. It is 6 and this is 1. Which means that so 8 gear cars and 6 gear cars are not showing significant effect. There is no significance difference much between 8 gear cars and 6 gear cars, but these first two groups are completely going to be significant, which be because of these two p values are less than 0.01. Now what is the interpretation? If the p values are less than 0.05, significance exists, we are going to reject the null hypothesis. But here so significance is not identified, the p value is above 0.016. Now with this we can say that we are going to accept the null hypothesis. There is no evidence to reject the null hypothesis. What is the null hypothesis in these cases? The pairwise groups are performing equally, their mileage is equal. Now final decision what we can do, 6 gear cars and 4 gear cars on an average their mileage is significantly different, not same. Around 6 kilometers average there is a significant difference. Now compare to the 8 gear cars and 4 gear cars, this is highly significant, almost zero, which means that the mean mileage of 4 gear cars and 8 gear cars are highly different. There is a huge difference between the mean mileage of the 4 gear cars and 8 gear cars. That's why you got see the difference is minus 11. Oh, 11 kilometers average mileage we are getting different than these two groups. And now go with these 8 gear cars or 6 gear cars. You have the differences minus for just 4 kilometers. 4 kilometers only mileage is different average and an average. Their p-value is less than, so more than 0.016, which means that, so we can conclude this one. 8 gear cars and 6 gears are not much different exist between their average mileage. So now we can say that 8 gear cars, 6 gear cars, anything you can find, you will get approximate same mileage on an average. There is no much difference exists between these two different types of car cylinders. But if you are going with 8 gear car, 8 cylinders, sorry, I'm saying gears, no, sorry, cars. So eight cylinders, right? So 8 cylinders and 4 cylinders cars are different mileage. Six cylinders and 4 cylinders car having different mileage, but eight cylinders and 6 cylinders. So sorry, I said gears. Sorry. So 8 cylinders and 6 cylinders. So these type of cylinders cars are giving approximately equal mileage. So now easily we can climb, right? So you can buy 6 cylinders car or 8 cylinders cars. No problem at all. Okay, why? Because their mileage is mean average mileage is approximately same. There is just we are getting only difference of 4. So this is our evidence. So like this, further we have to go for investigation about the ANOVA when there is a significant difference exists in the ANOVA table. If there is no significant difference, no, I mean p-value is above 0.05, no, then no need to do any investigation. Why? Because we are going to accept the null hypothesis. On an average, the cylinders, different cylinders of our cars are giving equal mileage. But in our table, we got the rejection of the hypothesis that, so the average mileage of different cars having different cylinders is not equal. Now we considered the multiple comparison test using TUCKHSD. We pairwise comparisons we did, and in the pairwise comparisons we came to know that, so 6 cylinders and 4 cylinders cars, the mileage is approximately different. On an average 6 kilometers they are giving different mileage, and then the p-value is less than 0.016. So it is a significant evidence got that, so these average mileage of these 6 cylinders and 4 cylinders cars are not equal. At the same time, 8 cylinders and 4 cylinders, so 8 cylinders and 4 cylinders cars are having huge difference in their mileage. So we can see the p-value is up to almost 0, and their difference is also minus 11. Now coming to the last one, so 8 cylinders and 6 cylinders cars. See, these type of cars approximately giving equal mileage. Our p-value is above 0.016, and the difference of the mileage, average difference of the mileage is minus 4. I mean 4 kilometers only average mileage difference. So we can conclude that, so 8 cylinders cars or 4 cylinders cars doesn't have any much effect on the mileage. Both are giving equally. So like this, we have to give proper justification about our comparisons. I hope you understand. Okay. This same technique, say copy and paste instead of cylinder. Gear. If I take gear, gear is also three. Let simply quickly I will go with this. I said gear, no, that's why I'm going. See, 3 gears, 4 gears, 5 gears. So 3 gear cars are there in our data. Some are 4 gear cars, some are 5 gear cars. Okay, there are 3 groups are there. Now these 3 groups I have compared their mileage. Now what I got the ANOVA, summary of ANOVA. So summary of ANOVA is P-value against significance. What is the significance indicates? So the average mileage of the different cars having gears based on the gears is not equal. Okay, so p-value is less than 0.0. We are going to reject the null hypothesis. I mean mean average mileage is different according to the gears. Now I have performed TUCKHSD. So let's go with TUCKHSD. So once we perform TUCKHSD, so 4 gear cars and 3 gear cars compared, their difference is 8 mileage. What is the p-value we got? So generally, what is the p-value here? We have 0.05. So 3 groups, right? Divided by 3. So 0.016. So if I take 0.01, so which is less than, which means that significance identified. So 4 gear cars and 3 gear cars giving different mileage, not equal. Now go with 0.09. 0.09 is less than 0.01. No, so it is greater than 0.01, right? So 0.09 is greater than 0.01. So which means that insignificant. P value is not less than. So we are going to accept the null hypothesis, which means that 5 gear cars and 3 gear cars are giving equal mileage approximately. Okay, their difference is very less. And here 0.42, which is more far than the 0.01. Again, we are going to accept the null hypothesis. P value is not less than 0.01. So these two cases insignificant, which means that accepting the null hypothesis, and in this case, so rejection of the null hypothesis. Now, what is the final interpretation? We can say that 5 gear cars, 3 gear cars approximately having equal mileage. At the same time, 5 gear cars and 4 gear cars also, there's only small 3 is different, their mileage. So with this, 3 gear cars, 4 gear cars, so sorry, 5 gear cars is having coincide mileage with the 3 gear cars, and 5 gear cars is having coincide with the 4 gear cars. Their approximate their mileage is same, but there is a difference between 4 gear cars mileage and 3 gear cars mileage. So 5 gears car is mingling going with 3 gears and 4 gears according to the data. So but 4 gear cars and 3 gear cars are not having equal mileage. So like this, we can go for the interpretations. I hope you understand. Okay, so this is what I want to convey here. And yesterday, some faculty I asked that, sir, what is this 1 way an hour? What is this 2 way an hour? And one more question also they have mentioned that. So T test is performed for less than 30 sample size. Yes, sir. So this is what I'm teaching here is I'm teaching in a layman purpose, not pure statistician purpose. If I want to teach any technique pure statistician oriented, then I cannot perform any model here without verifying assumptions. Assumptions must and should we have to consider, and all the constraints for a particular technique we have to consider. So without testing, without doing all these things, we cannot claim that or we cannot perform any data. Just as a layman purpose, I have shown that is I'm giving clarity for the papers. Okay, here, sir, here I have taken this sample is 100 observations. Yes. So to show you the significance of the or insignificance of the model. Okay, just for the purpose only. But generally, we as per you as you said, sir. So T test will be performed when it is a small sample size test. Okay, but it should be less than 30 only. Just randomly I have taken observations that is 100, 150. Okay, yeah, fine. And one more question also, that is 1 way an hour. What about 1 way an hour? What about 2 way an hour? Yes, the main motto I said, what is the use of ANOVA? Further investigation you have to learn. But otherwise, if you want to, if I want to teach each and every part, no, these 6 days may not be possible. Now see, we are at the last day. Still, I am performing ANOVA only. So I did not perform high dimension techniques. That is PCA, discriminant analysis, cluster. There are list many are there high dimension techniques. That's I didn't touch till now. Why? Because this is not enough to discuss within 6 days the entire statistics. Okay, the main ANOVA purpose is to compare the more than 2 group means. You can compare directly with this ANOVA. Further, for example, you have to investigate only one side. Either you want to compare row wise, then you will go with 1 way ANOVA. No, sir, I have to compare both directions, rows and columns, both the ways I have to compare. Then you can go for the 2 way ANOVA. Okay, so and again, in both the directions, is there any single observation per cell or more observations per cell? Or in the one cell, if I take row wise, column wise, you will get one value, no? So in case if there are n number of observations are available in a particular cell, then we have to go with one more ANOVA. So 1 way ANOVA more than or 2 way ANOVA more than one number of cells in the data. Like that, we have to go further investigations. And ANOVA, if you want to perform, generally we have to based on 4 assumptions. We have to verify testing of normality, homoscedasticity, independent observations, zero covariance correlation between observations. All these things we have to verify. So just as a layman purpose, I'm giving a talk that so general in particular situations where these techniques will be applicable. Where how to apply this? How we have to apply these techniques. So once you have that idea, then we can go for further investigation. Now I know ANOVA how to perform this ANOVA per particular data. Okay, now we can go. So how you want to compare? Now see, for example, here you want to compare. Here I have compared cylinder wise and gear wise. No, sir, both the directions I have to compare. Means you can multiply here. or you can take addition, factor, cylinder plus, factor gear. 2 and we will get. Codes are very simple, sir. Just my motto is that just you have to give a clarity about what technique this one and when we will apply, how to apply in R. Further, literally, you have to learn. Okay, fine. So this is what I want to convey here. And finally, one small high dimensional data technique will perform, and then we can wind up, no issues. So today here I will discuss uh, PCA. This is why I'm taking this high dimension technique is nothing but so many people will work this technique PCA. Many of you have listened this word also. PCA. What is mean by PCA is nothing but principal component analysis. It is a basic step but high dimensional data technique. This one everyone will follow this basic text PCA, but many people require this one. Why? Because what is the main motivation of this PCA is nothing but so PCA is nothing but it is a dimension reduction technique. Why we need this is nothing but nowadays everywhere data we are generating data day by day. So for example, we are using our mobile phones, right? So let's take that we are all using in Instagram, no? See, let's simply put it in Instagram, how many reels you are watching per day, how much time you're spending on watching reels, or how much time you are doing charting. So these are all data. We're generating data, no? I'm saying only social media data, not others. Okay, how much time you are reaching college, how many hours you are studying. So otherwise, how much information you have loaded into your brain. So many things. It's a day to day. And in the hospitals, if you go, so how many patients are visited, how many blocks they visited, how many doctors are appeared for taking the treatments, how many operations they did, how many investigations, how many diagnostics happens, how many tablets purchased. So per day, per minute. So these are the many things we'll get. So data is everywhere nowadays and having a huge information. Simply if I take one data, the data is having lakhs rows, records, and thousands of thousands columns. So reading this entire data, let us say I have one big data. Everyone will call no nowadays big data, big data. So it's a large volumes of data if I have. Let's simply assume there are 10,000 columns are there and 1 lakh rows are there. Now data dimension is 1 lakh cross 1,000, 10,000, which means that 1 lakh rows and 10,000 columns are there. So whenever we have these some large or big data, high dimensional data, so taking all the observations into analysis for our consideration will be difficult, will be hectic to us. And also the programming languages will not handle also. Sometimes if we have large volumes of data, which will go some misleading or it takes a lot of time and cost. So whenever we have a data is very huge, then without losing general will last it without loss of generality, we will say, right? So we'll add both sides log, we'll add both sides, differentiate both sides without losing generality. So like that we will do, right? Or without losing of generality, we will add both sides plus 5 plus 6 for our easy way of conversion of the derivations. The same situation without losing a general information about the data, so we can convert this entire data into small number of variables, the small number of rows. Okay, that's dimension is reduced. So to reduce this dimension, we need PCA, principal component analysis. And this PCA generally works on the columns. If you have 10,000 columns and you want to convert this 10,000 columns information, you want to convert into any small number of columns, as that we can do with PCA, principal component analysis. That I will show you how to do this dimension reduction, how our programming will help us. Okay, and this is only we do column wise, right? For example, if you want to perform row wise, row wise I want to reduce my data. Let us say 1,000 students are there. In these 1,000 students, some are having similar characteristics. Let them make into one group, one cluster. Some students are having similar characteristics. For example, they're coming by bus, let them into one group. And some students are intelligent, they have high IQ levels, make them into group. Like that, the data, if you want to make into row wise as some clusters, the same word cluster analysis will work. So cluster analysis will work it's one kind of dimension reduction. Directly, we should not say it is a dimension reduction. So it's a kind of dimension reduction to reduce it, to make the data into some clusters so that easily we can perform. So in the cluster, we are just making some clusters based on the similar characteristics or dissimilar characteristics, and we are decreasing the variation within the cluster and increasing the variation between the clusters. So row wise the data making into clusters, that's indirectly reducing the dimension, cluster analysis will do, and PCA directly will do the dimension reduction based on the column wise. Okay, these two techniques are very important. Okay, here I will teach the PCA to you people, and cluster analysis is simple. Just search in Google, you will get the code. Okay, by the time permits, I will teach that also. Okay, no issues. Okay, fine. Why? Because again 4:15 I have some meeting, so due to that I may not. I'm thinking that whether it may be possible or not, we don't know. So just I'm going with PCA. Then you can work on CA also. Now PCA. So principal component analysis. I hope you and I have given some little clarification about this my PCA, how the PCA will work in our data. Okay. So PCA is dimension reduction technique, works on the column wise. So if you have large volumes of data, going for the reduction of the data without losing general information. Okay. Most of the information will be gathered. We can take the into our data analysis. Okay. Let's go with PCA. So if you want to work with this PCA, we need to install the packages DPLYR. It's a package name. Okay, this package is required to learn this PCA. Okay, so is required PA package required. So DPLYR, right? So first let me search whether I have installed or not. DPLYR. Already I have installed. Why? Because already I have practiced this one. So DPLYR package is there. So if you want to go for installation, so DPLYR. So let's go with the latest package. Any update is there or not? We don't know. Just I'm installing this one. Yeah. So package is installed. Just again I will read back. Again I will search DPLYR. A grammar of data manipulation. Just I'm loading into my console. Yeah, loaded. So this DPLYR package so is having PCA command. So PCA command is nothing but just I want to simply directly I will perform without having any let's go with some data we'll take, then we'll go for any data. So we'll see any data set, otherwise we'll go for empty cast data set. I need some data which is having some at least 15 to 16 observations. Which is the data set is having more number of observations. Anyone is having idea about the data sets? Anyone practice which is having more number of observations? I mean, more number of variables. If you have, let me know. Otherwise, I'm searching here. Iris dataset is having only 4 variables. MTCAS 11 variables. And then anyone is having idea about this data sets which is having more number of variables? Swiss is only 2 variables or 3 variables. Tree is also very less number of variables. Women is only 2. Any idea, sir? What is this chick weights? Only 2. Or CO2.
Someone is okay, please keep it.
Faithful data is have. Faithful. This is also having very less. Then we'll go with again with empty cards. Why we need to waste the time? So why I'm searching is nothing but, so if you have more number of variables, no, that will be best. Why? Because PCA will be high dimensional technique. Okay, even less number of variables also we can reduce. If you, for example, let us here I have 11 variables are there. So these 11 variables I cannot take, sir. Let me give some reduction of this data so that I will take 1 or 2 variables. So 1 or 2 variables only I will take. I'm not taking 1 or 2 variables from the data. That is selection of variables. So we are not selection here. We are converting this entire data into some smaller number of variables. Okay. Yeah, fine. Let's go with the empty cars data set. Again, why you need to waste? Okay. So head of empty cars. Yeah. So these are the 11 variables, right? For example, I'm in a situation that these 11 variables I may not be able to consider into my data. Let us simply, I will go with visualization of the data. So I cannot visualize these 11 variables because of 11D. I mean, more than 3 dimensions may not be exist. So I will go with pairwise comparison, that is matrix scatter plot. So now, sir, if 3 variables are there, can you give me the entire information of these 11 variables into any 2 variables or 3 variables, so that I will get how much of information I will get, so that I can visualize my data in using 2 dimension or 3 dimension diagrams. Yeah, that we can perform using PCA. Okay, so now I will perform the PCA, so easily I will understand. So PCA is nothing but, so if you want to compare the principal component analysis, the code is PRCOMP. Just once I entered this one, automatically we got. So PRCOM, principal component analysis. Simply just give data. What is our data? Empty course. Empty cards. And here one more argument is important, that normalization. So whether you want to do the normalization of your data or not, normalization is different, normality is different. Don't compare both. So normal, I'm not saying normality, normalization. So there are different normalization techniques are there. So what is the main different main purpose of this normalization is nothing but, see here I'm reducing the data, right? And data is in different formats. So there are different variables are there. See here, my MPG, miles per gallon, it is in a gallon wise. What is the mileage we have given? Okay, so cylinders, it is a count data. Displacement, it is a continuous data. Horsepower, drag, weight, cubic are continuous. And volume surface is a categorical data, binary, 0 and 1. AM is a binary. So gears, so different gears, category data. Curve, category. So data is different, is a combination of different data types. Okay, now all these variables, we are not in the same platform. Okay, we have to make them into same platform, then only we can go for the any further classification or any comparison purpose. Am I right? Generally, see, this is, we know, right? For example, if I take one fish, I will ask them, I will give one competition. Generally, we have seen this story also many times. So if you give a competition of a fish and monkey to climb a tree, so both are in a different scenarios, different platforms. So fish in its entire career will not climb the tree, but monkey easily can climb. At the same time, if we are putting on a swimming competition, fish easily can do, but monkey cannot. So the platform is not same for both the animals. The same situation here, data sets or data variables are not in the same platform to make the comparison or to get to go for in one stage of or one way of performing analysis. So what we have to do, we have to make all the variables into one platform. Then we can go for the comparison purpose, or we can do the analysis further. So this is required. That is called normalization. So we are taking all the variables into the same platform. I mean, we are converting into some zeros and one, or so we are taking from 0 to 1. The data is normalizing the data into some limits. See here, MPG, if I take 21 and 22, like that we have. And cylinders, 646, very observations are very 6464 only. Displacement above 100. Next, MPG 110, 111. So drag 3 points. See, the different ranges also different. So now if the ranges are different, then no use of comparison. Why? Because mileage is different range, cylinders is different range, like that. So now what we have to do, we have to convert all these observations to one platform to go for further investigation. So to do this one platform, we are doing normalization. So in statistics, we are doing normalization. So here, generally raw data is always should be, we have to do normalization. Okay, because our data variables are not in the same range, same not platform. Okay, remember that one. So to do that one, just give one more argument, scale. Scale, don't not scale dot, just going with scale. Scale equal to, not any function also, scale equal to true. I am doing true if you give an option, no. So we need normalization of the data, then create the principal components. Okay. So I will perform this one. So instead of performing directly like this, let's store this one and we'll go for direct summary. Let us seek principal component PCA. Just I am taking PCA only. So I have performed this one. Yeah, executed. Take the summary of this model. PCA. Yeah. Just go with this increment. Again, I will perform. Then we'll understand. Yeah, see this one. Hmm. See the principal component analysis. Yeah, so first I have taken summary, then we'll go for the components, what are there inside. Okay, that's why instead of directly showing this principal component command output, I have taken summary for you people. First I will show you, then we'll go for the first we understand this one, then what the component each one will tells us. See in the data, it will not. I said no. It is a dimension reduction technique. It is a dimension reduction technique, but it will not tells us so, for example, if you have 10,000 variables, you have to take 100 variables. You have to take only 50 variables. Like that, it will not reveal. It will tells us. So, if you have 10,000 variables, 10,000 components will give. Now, in this 10,000 components, how many components you want, you have to choose based on the how much information that components are explaining. See, in the data, we have 11 variables, right? So, 11 components has been created. If you have 10,000 components in the data, 10,000 components will be created. Now it is your choice that how many components you have to select for your data. Okay, so how to select is nothing but here you can see this. Proportion of variation. This is a main value. Proportion of variation and cumulative proportion. What is this proportion of variation is nothing but eigenvalue. I hope any mathematicians here, you will know that eigenvalues and eigenvectors are eigenvalues are eigenvectors. Both are same. Okay, I will pronounce as eigenvalues. So this is nothing but this is 11. This data matrix now 11 variables. So for this data matrix, we will find the variance covariance matrix. What is this variance covariance matrix? 11 variables are there. So every variable there is a variance. Variance we know, right? So that what is the deviation between from data point to squared deviation between data point to mean. So like that we'll find variance for each and every variable. There are 11 variables, 11 variances. Now covariance. So what is the covariance between first variable to second variable? What is the variance between second variable to third variable? Like that we can find the covariance between all the variables. Now if you keep all the diagonal elements in the data matrix, in the covariance matrix, all the diagonal elements will be the variances, that is 11 variances, and non-diagonal elements are called covariances. So variance covariance matrix, one big matrix you will get. So matrix order will be 11 cross 11. Why? Because there are 11 variables are there. So 11 variables are there. So for this data, if I calculate the variance covariance matrix, multiple data, okay, variance covariance matrix, so you will get 11 cross 11 big matrix. In the big matrix, so diagonal elements will be the variances and non-diagonal elements will be the covariances. Now from this covariance matrix, if you find the eigenvalues and eigenvectors, you will get these are the values. 11 eigenvalues you will get. Why? Because the variance covariance matrix is order 11. So here I have highlighted, no, these are the eigenvalues of the variance covariance matrix. See, first one is proportion of variance 0.6. Second principal component eigenvalue is 0.2, next 0.5, and so on. These are the eigenvalues are arranged in a sequence. Okay, now if I take the first component, principal component from the data, the first principal component is explaining 60% of variation. 60% of information can be extracted if you take only one variable instead of taking 11 variables. If you take only one component, PCA only one component, if you consider this one component is enough to explain 60% of information. The percent 60% of variation we can explain about the original data by taking only one component instead of 11 variables. So what is this component? How we can look at the components? A PCA, the components are the linear combination of the original data observations. Maybe it will be like that. So let us say, if you take example, I will give PC1. So what we have got, PCA1, right? So let us say, so PC1. So maybe this PCA1 is a linear combination of the some variables. Let us say I will show you that also. Just I'm running 2.3 into let us say CYL cylinder plus let us say 5. This is the random number I'm giving 3.5. So into let us say wait. See, this is the linear combination of original data, cylinder and WT. So if I substitute cylinder values and WT values, what 32 observations we have, if I substitute, you will get PC1 32 observations. If I substitute 32 version data points are there, 32 cylinders values and 32 W2 values, you will get 32 PC1. That one variable, now newly created one variable, now that PC1, that variable is explained 60% of variation within this original data. Next, second PCA component is explaining 24%. Now, if I take the cumulative proportion for PC1 and PC2, we will get 84%. Now, if you go for third one, 89%. If you go for fourth one, 92%. So, how much difference? 89, 92, only 3. Here is 5 difference. Now we can decide that these 3 components are enough. See, PC1, PC2, PC3. So these 3 components, each component is a linear combination of the original data. Now, if I substitute the original data, you will get a new variable, that is PC1 one variable, PC2 another variable, PC3 another combination variable. Now, these 3 components are enough to explain 89% of variation about your original data. Approximately 90% of information you can extract with this only 3 variables. You can represent about your entire data instead of collecting the 11 variables. Now take these 3 variables and you can work on your data analysis. Easily you can draw 3 dimension, no? Easily you can fit a regression model, no? With 3 variables. Easily you can fit ANOVA, no? If you want to compare the groups, simply we can do instead of going with 11 variables. No, sir, I will increase some more percentage. Let us say 92%. 92% information if you want, take the 4 components. So now the 11 components are reduced into 4 components. Like that 94, 96 is the cumulative proportions. So each and proportion we are adding. So this 94 plus 0.01, 96. 96 plus 0.02, we got 97. Let it keep on. If you add no, completely final component will get 100%. If you take all the components, you will get 100% of variation. But what is the use of performing PCA then? No use of performing PCA, no? If you consider all the components, you can take original data itself, no? Why you have to consider the PCA components? So PCA components will be useful. So we have to take, so by seeing this percentage of variation, okay, how much percentage of variation, if you want, accordingly you can choose the components. Here see 92, just I'm saying why I'm saying 92 is nothing but, see here 94 next component. If I take the next component also consideration, 5 components will together will give 94, but 4 components giving 92 and 3 components is giving 89. 3 components is fine, no? For getting extra 4%, we need to consider 2 variables. Into 2 components where observations we have to consider. That is may not be good, no? I mean, it again going to be burden, no? So dealing of 5 variables, no? So let's go with 3 variables. This is fine for us. So 89%, around 90% of true information we can get the from the components. Okay. Now we'll visualize this components PCA, and this is the standard deviation between standard deviation of each and every variable. Okay. Yeah, now I will visualize this PCA values. PCA, see here. See here, PCA, standard deviations we got. Okay, otherwise we'll go with PCA dollar. Rotation is fine. PCA center. This is MPG. Okay, individual values is giving. PCA dollar. Scale we take. It is also single values representing. I want full data matrix. That's why I'm searching. Let's see. PCA X. Three six. This is fine. See here. PCA dollar. Take this X value. Original data set you will get from the data set. How this data components has been created. Okay, just take the PCA X. This is the data actually. We got this one. Now see here. Just a minute. Instead of going this original data, so you people easily will understand if I go with rotation matrix. So don't want to get more confused. Both are same only. Just we'll go with this one only. Unnecessarily we create a problem. Okay, fine. See, sir, here. See, this is the PC output I'm getting. So I got this PCA. Okay, these are the standard deviations what we have seen in the previous summary of the PCA. Now here, rotation matrix. This you can consider. See, PCA1 is a linear combination of these variables. So minus 0.36 into MPG plus 0.37 into cylinder plus 0.36 into displacement plus 0.33 into HP. So if I take all the these are one linear combination and if substitute all the observations of this data, you will get a single value, single observation, single value for each every combination. So if you have 32 observations, if we substitute 32 values in PC1, you will get. Same like PC2, 32 observations you will get. PC3 32 values, PC4 32 values, PC5 32 values. Like that you will get 32 observations in each every variable. Now how many variables you will get again? New PC combination 32 observations, each one is having 11 variables. So 11 variables you will get. So each variable is having 32 observations. Now with this, so what we have seen previously, priorly what we can see, sorry. Priorly. See, PC1 is 60%, PC2 24%, and togetherly PC1, PC2, 3 is 89%. Now you can take these three variables only. What is the output we got? Final, this one. So first linear combination, second linear combination, third linear combination. These three linear combinations are enough to explain about your data. 90% true information we can extract. So easily we can work on this one. So does not worry much about the remaining linear combinations. I hope you understand the peoples. And you may ask, sir, you are taking all the variables into consideration to get a one linear combination. So what is the benefit again here? Yes, sir. So we are, it is a PC is a linear combination of these variables. But so once we have linear combination or substitute the values, you will get a single variable, no? Single variable is a linear combination representative of all the observations. So you want to explore your data, the original information you have to exhibit with a less number of variables. So that's why it is taking linear combination, many all the variables, so into representing a single variable. And sometimes you may see that. So sometimes you will get the coefficient is 0. So you will not get all the variables into linear combination. Okay, but luckily here we don't have any zeros, so all our values are showing. So sometimes generally we'll get the PCA, the values will be 0 for some particular coefficients. So in situation the linear combination will be very less. Okay. Yes, sir. If you have any doubts, you can ask, sir. Actually, I have one meeting, sir, with my register, sir. Here I'm a food warden, so I have one meeting with the schedule. That's why I'm stopping here. If you have any doubts, you can ask. And then further in this, I mean, I have given list of topics that I will discuss. So in the topics, I missed this CA cluster analysis. Okay, so almost I have covered what the topics I have given in the proposal for the 6 days. So in this, I have missed one thing is CA cluster analysis that I'm giving choice to you people to learn. Okay, CA is on the cluster analysis, making the clusters. We are classifying the data into their similarities and dissimilarities. The code I will share with you people, you can practice that one. If you have any doubts, you can ask, sir, on this PCA or ANOVA.
Yeah, dear participants, please ask because speaker has to go somewhere.
Please send me feedback link. Okay. Here I'm typing my email ID and then pass. What is that? Phone number. If you have any doubts or if any clarification required about this session, just send a text. Just send a text to me or WhatsApp me. Okay. My mail ID is siva.g@vatap.ac.in. So this is mail ID, and then my WhatsApp number is 730-633-6411. So this is my WhatsApp number. Just I will stop my presentation. You will easily see that.
Okay, sir. Thank you, sir. Thank you for your.
Yeah. So you can use this
successfully completed.
mail ID and then number. So if you have any doubts anywhere, so directly you can ask me, or you can send a WhatsApp text to me easily. So with your code, just take a screenshot, sir, this code is not running, there is an error in this code. So you can directly can ask like that, immediately I will give a reply. Okay.
Yeah, okay, sir. Thank you, sir. Anyway, we have successfully completed this, sir. Because
And
of
then
this,
sir, for the, I mean sir, the Vinod sir, and sorry for the last day, I didn't inform to you also. So just a few minutes back, I got a mail from the
it's
register
okay,
sir.
okay, no
So
problem,
all the
sir.
wardens
Actually,
are,
no, 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 don't worry, because within the time only, exactly you have taken your time. But beyond time, you did not given. But actually, what the
yeah,
time you
just
have mentioned, we have taken.
yeah. No, I have not given information to you also, right? I got at
Yeah, yeah,
4:53. I got the mail, sir.
yeah, yeah, yes, yes.
So
Because directly you have said now only.
yeah. So
Yeah,
the,
no
anyway,
problem.
last day
Okay, okay, sir. Thank you.
I thought to spend some much time on the last day at least. Okay,
Yeah, yeah.
fine.
Okay.
That's
Anyway,
why I'm
thank you,
sharing
sir.
my mobile number and then mail ID with you all. So take a
Okay,
note
sir.
of this. And if you need any help with the R programming language or for the data analysis coding, let me know. I will work with you.
Okay, sir. Thank you, sir. Thank you very much, sir. So, dear participants, I will send the feedback link in the chat box. Please fill it. And also, the certificates will be issued soon on Monday. Thank you. If any doubts, please ask. Sir is still waiting. Sir, I have to leave. No. Okay, Shiva, sir. I think no one responds. Thank you, sir. Thank you for
Yeah,
your valuable.
thank you, sir. Thank you so much, sir, for the opportunity to discuss with you people. Okay, thank you so much, Vinod, sir. This is second time we are going with this.
Yeah, 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 yeah.
So say my big thanks to your institution also, sir,
Sure, sure, sir.
to giving invitation for me and then to bear with me.
Thank you, Shiva
Praveen Kumar,
sir.
sir. Please fill. Yes.
Sir, Pawan sir, thank you so much, sir, for your feedback on time.
Thank you, sir. You have given a lot of information regarding this R programming because I don't know the basics, but now I learned almost 30 to 80%. I learned these things. Thank you so much. If I have a doubt, I'll
Yeah,
contact in WhatsApp
sure,
number.
sure, sir. I got a message from you already. Thank you so much, sir. And then, sir, what I said, no, I said in I think second class something. So
Yes,
do mistakes while writing the codes.
yes, sir.
Don't did perfectly. See here, I did. I'm also practicing like I'm working with codes. So I will
Mm.
not remember complete code and I'm pasting in front of you. Why? Because if I'm doing like that, no, you will not see what type of error I will get.